We're going to do our first lab of the year today, the purpose of which is to find the velocity of a little car. Okay, that velocity should end up being pretty much constant velocity because there's not very much friction between the ground and that car. So the problem, always phrased in the form of a question, always phrased in the form of a question. I'm giving you the problem this time. I won't always give you the problem. When I don't, you got to remember to always phrase it in the form of a question. Today's problem is, what is the velocity of a low friction car moving on a horizontal track? Got it? So we're looking for a number. Okay, what is the velocity of this little car, this low friction car, on a track? Okay, 3.0 meters per second, 27.9 meters per second, whatever the case may be. Now, you have to, in addition to your problem, you have to indicate your materials/apparatus. The good news is, for this lab, the materials and apparatus are very, very simple. The bad news is, you've never used the materials and apparatus that we're going to use for this before, so there's a little bit of a learning curve in terms of learning how to use it. Okay, we're going to collect data all electronically today. You're not going to use a stopwatch. You're not going to measure any distances. You're not going to do any of that stuff. You're going to measure everything electronically using what we call a smart card. Okay, this smart card will hook up to our phones, and it will wirelessly, via Bluetooth, send data for position and time to your phones, which you'll export to Google Sheets and then plot a graph with. Does that make sense? So what are we going to use for materials? Well, you see pretty much all of it up on the board already. You get your smart cart. Some of you will have a blue smart cart, like in the picture here. Some of you will have a red one. Doesn't really matter. Okay, and all of you will have a track. The track in this picture is one of these metal tracks that you see up here. Some of you will be using these white tracks here. Okay, if you're using the metal tracks, it's perfect because the grooves in the metal track correspond exactly to the wheels in the smart car. If you're using one of the white tracks, which you can see we're actually making by combining two of them with duct tape, there's no tracks, no little tracks to put the wheels in. That's okay. They'll roll nicely along this flat surface while it's sitting on the floor. The reason we want you to use a track rather than just have these things going on the floor is because these carts that you're going to use cost almost $300 each, and they're very low friction. We want to avoid collecting dust and dirt from the floor by rolling it on the floor. So we always want to use a track with it, whether it's one of the tracks that are made for it or whether it's one of these improvised tracks that are white over here. Does that make sense? So you've got a smart cart, you've got a track. The only other thing that you're going to need is your phone. One of you in each group, that is. Not even all of you are going to need to use a phone, but one person in each group is going to need to use a phone. iPhone or Android. I will say, if you're using an iPhone, that's what I have, so I'm more comfortable with troubleshooting if you're having trouble. If one person in your group has an iPhone and somebody else has an Android, maybe pick the iPhone, because as I say, if you're having trouble with it, it's a little bit easier for me to troubleshoot it because that's what I have myself. Does that make sense? In the end, though, it should work for Android as well. Shouldn't be a problem. All right, so that's what it looks like. This is the cart that you're going to send down, giving it a little push. Just give it a little push and then let go of it. You're going to send it down the track to approximate a constant velocity or uniform motion. Does that make sense? Now, there's a couple things on this that I want to draw attention to. There's a little light right here that's for the battery. Okay, if that's green, you should be fine. Okay, there should be no issue with that whatsoever. They're all charged, so nobody should have a problem with that. Okay, here's your little Bluetooth to tell you that it's connected. Beside that, and this is important, beside that is a number. You can't see it very well on the screen up here, but there's a number there. Each cart has a different number. When you're connecting that to your phone, you need to make sure that you're connecting your number. Does that make sense? You're going to see up to, depending upon where you are, up to 8 of these things appearing as options to connect to. Don't just connect to the first one you see. Make sure you're connecting to the one that has your number on it. Otherwise, you're going to end up getting data from somebody else. from somebody else's card. Okay, and they may not be pushing it at the same time as you're pressing start to collect data, so it's not going to work out. Finally, this thing over here, this is the little on-off symbol, but the switch is actually on the side of the apparatus, on the side of this smart card. Just a little button you're going to press, and you'll know that when it's on because the little green light will come on. Make sense? All right. That's the apparatus. Man, that's simple, hey? Just a matter of how to use it now. You're going to push it down, okay? And when you push it down, you're going to press start on the app that I'm going to tell you about in a few minutes. It's going to collect data, and it's going to plot a real-time graph on your phone. That graph should be pretty close to a straight line because it's indicating constant velocity, right? Now, if it's not pretty close to a straight line, then the data that you're collecting is not very good. You should just do another trial. It's not a big deal. Do trials until you get what looks to be good data. Now, you may see, when you plot that graph real time, you may see it work out to be a perfect straight line. That's wonderful if it is. You may also see something like this. That's okay too. If you see something like this, it just means that you've got a perfect constant velocity right here, but right here, you've got a non-moving thing. In other words, you just started collecting data before you pushed it. Does that make sense? That's okay. We can deal with that later. So if you see that little thing right there, not a big deal. Similarly, you might see something that's wacky over here. That just means that maybe it's gone off the edge of the track or something like that. Okay, I'll ask you to try to avoid having it go off the edge of the track. Try to catch it before it goes off the edge of the track. But you might see something wacky up here indicating that it either went off the edge of the track or you touched it with your hand to stop it or something like that. That's okay as well. We can deal with that later. As long as you get this section in here that shows us a nice straight line for the position time graph, and you'll know it real time because you'll see it on your phone real time. As long as you get that, that's what we need. We can deal with those other things later on. Does that make sense? All right. Once you have a good graph on your phone, then you're going to export the data to Google Sheets, to your Google Drive, and there's a little instruction sheet as to how to do that, so don't panic about that. Okay, a little instruction sheet. Then you're going to share it with your group members. Now, each group member, listen carefully to this, each group member, once it's shared with them, will make a copy of it, including the original. So, Martin, it's your phone, let's say, that we're using here. Okay? You're sharing it, you're sharing your data with Marcus because you guys are partners. That's fine. I encourage you to share your data so that you don't have to retype everything, right? But when you share it with Marcus, he's going to right-click it and make a copy, and then you're going to make a copy of the original as well. So that when you're working off of it and plotting graphs and so on, each of you are making your graphs and your analysis based on the copy of the data, not the original. Do you know why I don't want you to do anything with the original? I don't want you to delete anything or add anything or plot graphs with the original. Because if you share the original with Marcus and then you start doing work with this, what happens? Marcus has all the work done for him, right? So each of you are going to make a copy of it and then do your work on the copy, and then neither of you are sharing work with each other. It's okay to work with each other and help each other out, right? But you need to do your work on yours, and you need to do your work on yours. Make sense? Okay, again, there's instructions for that. When you open it up in Google Sheets, man, this is what it might look like. I've got several trials on this. You can see actually 3 trials on this. Run 1, run 2, run 3. You may only have 1 run. If your first trial worked out really good, then you may only have 1 run, and it's not going to look quite as complicated as this looks. But if you have more than 1 run, 3 runs, 4 runs, 5 runs, that's okay. Don't worry about it. Okay, we can deal with that. In the end, you're going to end up deleting most of this data so that your data is going to look just something like this. 2 columns, time and position. I'll show you after we're done collecting data how to go about doing that. So don't worry about that right now. Okay? Now, from that, you're going to plot a graph of position versus time. Position being, which is the responding variable here, which is the manipulated variable? Position, manipulated or responding? Position would be responding, time would be manipulated. It's titled y-axis versus x-axis, right? Or position versus time. Okay? Don't worry about how to plot this graph right now. Okay? I'll walk you through that after we've collected our data. But in the end, you should get something like this that has an equation here. You can see that says 0.348x plus negative 0.0878. The slope of this graph is 0.348, and that corresponds to the velocity of my car. So, what was the problem? What is the velocity of this low friction car on a horizontal surface? We just found it. 0.348 meters per second. Make sense? Your conclusion, sorry, there's a couple analysis questions as well. You don't need to copy these down because they're there. There's a couple analysis questions that have been modified a little bit actually since I put this up. Don't worry about that. There's a template for you with the modified questions already on it, and I'll show you that template in just a moment here, okay? Firstly, we want you to identify what a straight line on a positioning time graph represents. We know that because we've done that the last 2 days. And secondly, there could be a slight, an ever so slight, sometimes, most times, in fact, imperceptible curve on your graph because it's not perfect constant velocity. I want you to tell me what that would mean, okay, what that would mean. And I want you to tell me if you get, this is exaggerated, but it could look something like this. I want you to tell me what that means, and I want you to tell me why on your, that's the second part of this question that's not written here, why in your activity could it look like this? Okay, why in your activity is it not quite a perfect straight line? Then it's your conclusion. And your conclusion will always relate to your hypothesis if we have a hypothesis. There is not a hypothesis in this lab. I'm not asking you to write one. In the absence of a hypothesis, your conclusion will relate back to your problem. What was the problem? What is the velocity of this car? So your conclusion is the velocity of a low friction car on a horizontal track is, what did I say, 0.348? Is that what it was in mine? Something like that, whatever it was from the graph, right? This is known because the slope of a position time graph, and so on and so on and so on. You're basically justifying where you got that number from. Okay, the slope of your position time graph. Does that make sense? Now there's one more thing that you need to add in here, and that is what we call sources of error. You guys have all done this before I was going to say junior high. I'm not sure if you've done any of these in junior high. Depends on whose class you were in perhaps, but certainly in Science 10 you've all done these. Your sources of error are 2 or 3. It's not a quantity, it's a quality thing. Okay, you need at least 2, but if you have 2 really good ones, good enough. If you have 3 good ones, even better. 2 or 3 good sources of error. It could relate to the procedure. Maybe there's something with our procedure that could have been better. It could relate to the materials. Although you might have, with the apparatus that we're using, you might have a tough time using one of the materials as a source of error because they're really, really good. It could relate to your time management. Okay? What it doesn't relate to is the quality of your partners or yourself. Don't say, Martin is a source of error because of whatever reason. Okay, that doesn't work. Okay, or don't say I made a mistake calculating this. Well, then just fix it. If you made a mistake calculating this, sources of error should not be human errors. Got it? Sources of error should not be human errors. Then give me for each of your sources of error a suggestion to improve it. So if you had an issue with your materials that you think could be better, all right, how would you make it better? And be specific with that. Don't just say, oh, come up with a better cart. Like, that's a little bit too general, right? If you have an error and you get a suggestion, fantastic. Be specific with your suggestion, right? One of the reasons I'm giving you almost a week to write this up is because I want you to have the opportunity to chat with me about these things, right? If you're not familiar with this, not so familiar with this, not so comfortable with writing things like this, come up with a couple ideas and then talk to me about it to see if they're reasonable ideas or not before we actually hand it in for marks. Make sense? Lots of opportunity to do that, right? So what are you going to need to hand in for this? You need a problem. We've already gone through this, right? But just in summary, we need a problem. We need your materials / your apparatus. We need your data / observations. We need your analysis, which includes your graph, and it includes those analysis questions. We need a conclusion, and we need sources of error. Now, the good news is, everybody right now, okay, you wouldn't know this because it only appeared at 10:05, everybody right now on Google Classroom has, along with the lab and the description of the lab and so on, a template created for them already. Hey, this template says Student Dickie, Constant Speed Lab. Yours will say Joe Smith, Constant Speed Lab, or whatever at Constant Speed Lab. Your name, Constant Speed Lab. You can do whatever you want to that template, and it's not going to affect anybody else. You can see that there's a lot of stuff in pink / purple, however you view that as, pink or purple. Those are little instructions. I want you to delete those. I don't want to see those instructions when you submit because I already know that stuff. Okay, that's for you, to benefit you, to help you. Okay, just to clarify a few things. You can still ask me questions in person, but you might not need to ask me a question because it might be answered for you right there. That make sense? So your problem, it says, remember to phrase the problem in the form of a question. Well, I already gave you the problem for this one, right? But normally, you'd have to remember to phrase it in the form of a question. Your materials and apparatus, you're going to list them, and it says a photograph can sometimes be helpful. Don't just give me a picture, but if you want to give me a picture, that can be nice. But you also want to list them, or maybe even just label your diagram. One of the things about a photograph, if I was doing this, I might like to put a photograph in it because it reminds me, as I'm trying to remember what all the materials were, it reminds me of that, right? If I'm looking at a picture, it's a lot harder for me to miss one of your materials. That make sense? Okay, if a photograph isn't mandatory, but it might be helpful for you. Data and observations. Notice I don't even have a hypothesis or procedure here. Why not? Because you're not required to do one for this lab. If on the next lab you're required to do a procedure, then that'll be in your template. And your variables and your data and, and your hypothesis and so on. If we scroll down here, whoops, lost it. We scroll down here, data and observations, that's the table that you saw, the 2-column table, right, time and position, not that big table. I don't want to see all that stuff. Okay, all we're dealing with is the time and position, so that 2-column table. Again, I'll show you how to get rid of all those other columns after everybody's collected the data. Then we have analysis. Okay, it says it will often include a table of calculated values. In this case, it will not include any calculated values. It will include a graph, and it will include answers to analysis questions, which are right here. These are the modified analysis questions. All I want you to do is type in your answers to the analysis questions right there. Don't delete those. Notice they're not in purple. Keep them there. Just type in your answers to those analysis questions. Then your conclusion. Yeah, it says if you have a hypothesis, this is what you're supposed to do. If you don't have a hypothesis, then relate it back to your problem, which is what we talked about, and then your sources of error. And again, remember to delete all of that purple stuff just for neatness. Make sense? Now, none of you have had me before, so none of you have seen the way that I mark it. Okay, the rubric that I use looks quite a bit different than the rubric that you would have used in the past. I like it, and generally I think my students like it because it's very clear what's expected of you. There's no ambiguity at all. Everybody also has this created for them in Google Classroom as well. You don't need to do anything with it. It's already there. Right now, it says for all of you, you have a mark, funny enough, of 0 out of 32. Don't worry about that. Okay, that'll get changed. Okay, you're going to go through all this. This is what's required: problem, materials, data, analysis, whatever. And it's kind of a checklist for you, kind of a checklist of what you need to do for this, right? And then beside that, you can see what that's out of. So for instance, if your graph is properly titled, you can see here, it's either a 1 or a 0. It's either properly titled, I put a 1 in there, or it's not properly titled, and I put a 0 in there. So it's a little checklist that reminds you of all these little things to watch out for. Does that make sense? It's more specific than most rubrics you see. I like that. I like specific because I think more detailed, more specific, I think provides you with a better opportunity to do a bang-up job on this and not miss some small little thing.